I'm going to tell you about specific resistance. Specific resistance is nothing but the definition of specific resistance is if the length of the conductor is 1 centimeter and area of cross section is 1 centimeter square, then the resistance of a conductor is said to be specific resistance and it is denoted by rho. And we know that resistance is directly proportional to the length of the conductor and resistance is inversely proportional to the area of cross section. Therefore, from 1 and 2, I can say that this 1 and 2, I can say that R is resistance is proportional to L by A, and introducing an proportionality constant, that is rho, R is equals to rho into L by A, where rho is called as specific resistance. And units of specific resistance are, in CGS system they are ohm, centimeter, or in SI system they are Siemens meters. And when I am going to the specific conductance, if the distance between two electrodes is 1 centimeter and the area of cross section is 1 centimeter square, then the conductance of the conductor is said to be specific conductance and it is denoted by K. And I thought C is equals to 1 by R because conductance is reciprocal of resistance. Therefore, C is equals to 1 by R. But I know the value of R as rho into L by A. Therefore, by doing the substitution, I will be getting that C into L by A is equals to K, where K is the specific conductance. And specific conductance also can be written in the formula that cell constant into conductance, that is cell constant is L by A and conductance is C. Therefore, I can write that specific conductance is equals to cell constant into conductance, cell constant into conductance. And units are ohm inverse, centimeter inverse. And conductance is of three types. We can classify the conductance in three types. They are specific conductance, and which is denoted by K, and equivalent conductance, which is denoted by lambda, and molar conductance, which is denoted by mu. And here lambda is similarly we will be writing lambda as, here we will be giving another stroke, but here we will be just writing as inverse of V. Inverse of V. It is also called as lambda. Please note this. And equivalent conductance. It is the conductors which can be shown by all ions. When 1 gram equivalent weight is dissolved in aqueous solution, this conductance is called as equivalent conductance and it is denoted by lambda. And equivalent conductance is due to the mobility of ions towards the electrodes, oppositely charged electrodes. And the relationship between specific conductance in equivalent conductance is lambda is equals to K into 1000 by normality. And units are simply ohm inverse, centimeter inverse, gram equivalent inverse. Ohm inverse, centimeter inverse, gram equivalent inverse. Ohm inverse, centimeter inverse, gram equivalent inverse. And then we will be going to this molar conductance. Molar conductance is nothing but just we have to replace the words, that is here we have written 1 gram equivalent weight, but here we have to replace that word with 1 gram molecular weight. Just we are changing the term equivalent into molecular, that is when if it is the conductors in which shown by all ions when 1 gram molecular weight electrolyte is dissolved in aqueous solution is called as molar conductance and it is denoted by mu. And relationship between mu and K, that is molar conductance and specific conductance, is mu is equals to K into 1000 by molarity. And units are ohm inverse, centimeter inverse, mole inverse, liter. And here there is a first factor which is affecting on conductance. The first factor that is affecting on conductance is dilution, that is when dilution get increases, specific conductance would decreases and equivalent conductance and molar conductance would be increasing. Specific conductance decreases as dilution increases, since the specific conductance depends upon the number of ions in unit area, whereas in molar conductance and equivalent conductance, the conductance would be getting increased as dilution increases, because it depends upon the mobility of ions, and mobility of ions increases as dilution increases.